Hello. In this video, I'm going to introduce rational choice theory. This is the neoclassical theory, really, of how individuals make all of the decisions that they make. But we're going to be looking at it specifically in the context of answering the question, why do people consume what they consume? You can already see the basic answer we're going to give from this neoclassical perspective. People consume the things they consume because those are the things that they like. In neoclassical theory, the focus is going to be on choice between alternative goods, rather than how the preferences for those goods are actually formed. It's assumed that people like what they consume, and they consume what they like. And the Latin phrase that goes along with this concept out of neoclassical theory is de gustibus non disputandum est. Now, I don't actually speak Latin. I'm not sure that's how it's actually pronounced, but that's as close as I'm going to be able to get to it. If you speak a romantic language, you can probably break down what this Latin phrase means. De gustibus, especially if you speak something like Spanish, you probably are familiar with gustar or me gusta. This just means of the things that people like. Non, of course, is not. Disputandum, of course, is disputed, and est is just is. So de gustibus non disputandum is really just saying preferences are not to be disputed. The things people like are not to be questioned as to why they like those things. Instead, neoclassical economists simply say people get utility from the things that they like for whatever reasons that they like those things, and what we want to see then is how they choose amongst the things they have to choose from given those preferences. So according to neoclassical economics, we are rational, individual, or autonomous decision makers, and we make our decisions based on two basic things. The first is what we call utility, which is just the term we use for the pleasure or satisfaction that people get from doing or consuming something, and that's given by our preferences. The second is the price of doing or consuming that thing. So we can break utility down into two related functions. We can talk about the total utility of something, say a cup of coffee, and we can talk also about the marginal utility of that thing. Total utility is telling us the total satisfaction you get from consuming some quantity of a product, say again a cup of coffee. Marginal utility is related to total utility. Marginal utility is telling us the satisfaction you get from consuming one additional unit of that product beyond what you've already consumed up to that point. So let me give you an example. Say you're loitering at your local coffee shop and you're drinking each additional cup of coffee, and let's say that goes from 0 cups of coffee to 6 cups of coffee. And suppose that given your preferences, we knew the total utility you would get after having consumed each cup of coffee. And let's just say we can put a number on that, although economists don't actually believe you could really put a number on utility. Let's say the numbers we come up with look something like this. For 0 cups of coffee, total utility from coffee, of course, is 0. After consuming the first cup of coffee, the total utility from coffee is 12. After consuming the second cup of coffee, total utility goes up to 20. With the third, total utility goes up to 24. With the fourth, we notice something interesting. Around the fourth cup of coffee, total utility actually maxes out. It stops increasing. You can think of this as, I've drank so much coffee, I'm not actually getting any more satisfaction. I'm just really kind of getting jittery. And we actually see this get worse as we consume the fifth cup of coffee. Total utility from coffee has gone down now to 20. And with the sixth cup of coffee, it's gone down again to 12. Now, what I want you to notice here is the marginal utility numbers and how they relate to the total utility numbers. Marginal utility, again, is just going to tell us the additional total utility we get from one additional cup of coffee. So another way of looking at that is marginal utility is really just telling us the change in total utility. As we consume that first cup of coffee, our total utility increases from 0 to 12. So the marginal utility from that first cup of coffee is 12. You look at that second cup of coffee. With that second cup of coffee, total utility increases from 12 to 20. So the marginal utility of that second cup of coffee must be 8. With the third cup of coffee, total utility increases from 20 to 24. So the marginal utility of that third cup of coffee must be 4. And then again, interestingly, when we consume that fourth cup of coffee, total utility doesn't actually increase, which means total utility doesn't change, which means marginal utility must be 0, reflecting a 0 change in total utility. With the fifth cup of coffee, total utility is actually decreased from 24 to 20, so marginal utility must be negative, reflecting that decrease of total utility. Marginal utility for that fifth cup of coffee then is -4, and you can see marginal utility for the sixth cup of coffee then is -8. And we can actually graph these numbers out, roughly speaking at least. We're going to assume continuous quantities, so you can talk about a fraction of a cup of coffee, and you get total and marginal utility curves that look something like this. Notice on both of these graphs, we've put the quantity, which is to say the cups of coffee, on the horizontal axes. In the graph on the left, we've put total utility on the vertical axis, and on the graph on the right, we've put marginal utility on the vertical axis. So what we're seeing here in the graph on the left is as we move from left to right, as the quantity of cups of coffee that we've consumed increases, our total utility increases as well, but you'll notice it increases at a decreasing rate, such that by the time we get to around 4 cups of coffee, our total utility actually stops increasing. It maxes out, and after that quantity, it starts to actually decrease. When you look then at the graph on the right, marginal utility, you see that marginal utility starts off relatively high. The marginal utility for the first cup of coffee was 12. The marginal utility for the second cup of coffee is 8. So marginal utility is positive, but you'll notice it's declining. At somewhere around the fourth cup of coffee, marginal utility actually goes to 0, which indicates, of course, that total utility has stopped increasing. And at quantities beyond 4 cups of coffee, marginal utility actually goes negative, reflective of, again, as we saw in the data, of total utility actually decreasing. And this relationship that we're seeing here, this particular set of marginal and total utility curves, is reflective of an important concept in neoclassical economics. It broadly goes by the phrase diminishing returns, but in this particular context, we'll call it the law or the principle, or really it's just an assumption of diminishing marginal utility. And all diminishing marginal utility means is that as we consume more of a good, the additional satisfaction we get will decline. When marginal utility goes to 0, total utility, in fact, will be at its maximum. It'll stop increasing altogether. So this relationship between marginal and total utility, you're going to see this come up throughout the course when we study the neoclassical models. You'll see total this and marginal this, and the relationship's always going to be the same. Marginal whatever is always going to be telling us the additional whatever from consuming or producing or whatever, one more of that thing in question, which is another way of saying marginal whatever is always going to tell us the change in total whatever. Graphically, I want you to ask yourself, what does marginal utility that we're looking at here tell us about the total utility curve at any particular quantity? If you thought that question through correctly, you saw that marginal utility is actually just telling us the slope of the total utility curve. We saw that when we began consuming coffee, total utility was going up, which meant its slope was positive, but as we consumed each additional cup of coffee, the slope of total utility got shallower, it got flatter, which is to say the slope got smaller. At around the fourth cup of coffee, the slope went to 0. That's the point where total utility is maxed out. You'll notice when we talk then about the slope of total utility, we're actually saying the exact same thing at each quantity that we would have said about the curve itself when we're talking about marginal utility. At the first cup of coffee, marginal utility is a relatively large positive number, reflective of the fact that the slope of the total utility curve at that cup of coffee, at that quantity, is a relatively large positive number. But as the quantity increases, as we move from left to right, the slope of total utility gets smaller, and marginal utility itself, the marginal utility curve, reflects that by decreasing. Once we get to that maximum point where the slope of total utility is 0, we see that marginal utility is also 0. But that should make sense since marginal utility is the slope of total utility. And as you can see, in quantities past 4 cups of coffee, the slope of total utility actually goes negative, and you see that reflected in the marginal utility curve by the marginal utility curve actually going below the horizontal axis, suggesting that marginal utility itself is negative.